So this is question 2 of the worksheet. And in this question, we're creating a function skip that takes in a linked list and returns a new linked list with every other element skipped. So now, one of the first things to look at if you're confused about what exactly is supposed to happen is the doc tests. And in this, it kind of indicates how we have some sort of linked list A, which is a series of 1, 2, 3, and 4. And after tossing into the skip function, we get 1 and 3. So now let's try to draw an example, and we can kind of see about how to start approaching this. So we have 1, 2, 3, 4, and I'm just gonna say it goes on. We just can't really see the end right now. And we want that to become something like 1, 2, 3, 2 onwards, where it's every other element. So the question is, how do we do that? Well, let's keep an eye on the first a few key things. Notice that this problem says that we need to return a new link. So let's have that as our starting point. If we need to return a new link, that means whenever we return something, it has to be using the link constructor. We have to be creating a new link object rather than returning a reference to the link list we are working with. So what that means is that likely somewhere we'd have to do return link and the creation of a link object. So secondly, we need to figure out, how do we do this skipping? Somehow I want it to be the case that this 1, rather than pointing to the 2, we reassign the pointer so it points to the 3. Well, let's think about how do we just make that jump. Well, making that jump is saying somehow that, or rather than using list, let me just call it link.rest equals link.rest.rest. So this is essentially what we're trying to achieve. This is not the exact code, but this is what we're trying to achieve. We're trying to say that the rest doesn't point to the next thing, but it points to the next of the next thing. And that's what we want to do at every other link. So we know that we have to create a link. So let me write this down. Create a link. We need to use link.rest.rest. So now the question is, how do we combine all these things together? Well, let's look at our recursive case, and then we'll approach our base case. So in our recursive case, we know that we're going to first have to return, because the question does say that we will return a new link. So at the end of the day, we are returning. And the thing that we're returning is, like we established, a link. Now this link, remember that it takes in a first and a rest. So what is our first going to be when looking at this example? It's going to be a 1. So that's equivalent to saying list.first. That's just us getting the 1 at the beginning of this linked list. So now the tough part is, how do we get the rest? Sure, we can just say, oh, let's just do list.rest.rest. And that's essentially doing what we wanted to right here. But the thing is, we have no guarantee that the future part, the later part of the linked list was correctly skipped. We're just assuming that the later part of the linked list is skipped, and we are skipping the current part that we're working with. So that's the problem. We cannot make that assumption, but we can do it with one simple change. And that's where we kind of, once again, use the idea of abstraction. Abstract away the details and try to understand that, try to believe that the function you are working with it does its job for a certain like set of components. So if we do this, we're saying, okay, let's assume the skip function correctly does this, like the job that a skip function is supposed to do on everything past .rest. So that's correctly dealt with, and all we need to do is take that chunk and combine it with our first element. So as a result, this is a valid recursive case. We've correctly combined our first with the .rest, and we are not making the assumption, or like now we can validly make the assumption that everything after this is also correctly functional and it looks correct, just because we assume that it does. So that's the recursive case. Now the question is, what is the base case? And to figure out the base case, you really need to understand what are the smallest units that the problem that we are working with can go. Well, where do we stop recursing in a linked list? That's kind of like when we're reaching a link.empty, because after that there's nowhere to go to. We're at the end of the link. So let's have that be one of our base cases. So if the link is empty, we need to do something. And now I know a lot of students have trouble trying to figure out, oh, what should happen in the base case? But like I mentioned in section, assume that the thing that was passed in was the base case. So assume that 61A called the skip function and they passed in an empty linked list. What should the answer be according to the problem? Well, it should just be an empty linked list. Like, we can't skip anything if there's nothing to skip. But notice I did link.empty instead of returning list. Sure, the values are the same. They're both empty linked lists. But doing link.empty means that I'm creating and returning a new link rather than the old linked list if I just returned list. So we got this base case, we got this recursive call, so it's kind of confusing what this last thing is supposed to be. And this is where you really need to figure out, what is the problem asking? Think about what can go wrong if we call .rest. If it was a 4-element linked list, we would get, in this case, if we're looking at the top example, we'd get the 1, we'd get the 3, and after that, if it was a 4-element linked list, we would stop after that. So in that case, we would hit our first base case, because in the very last frame, in the very last recursive frame, our list would be empty, primarily because in this scenario, this is an empty linked list, and we would say, oh, well, list is empty, let's return empty. But what if this was an even length list? In that case, we could have something like this. And as a result, we want the output to be 1 pointing to a 3 and a none. Now, this is the same result as the previous one, but the difference is that we would actually run into an error if we did not account for the different types of lengths, whether it's odd or even. And that's primarily because at a certain point in time, we would call this .rest when we do skip of list.rest.rest. So we just call it this.rest, but this is an empty linked list, so that would error out. So instead, what we need to do is we need to count for the case where it is an empty linked list that we're working with as our final component, or it is the case where we have one element left, right? Because if we have one element left, we can't do 2 hops when we skip. So when we have one element left, it's going to be the same thing as saying, oh, well, list.rest is empty, rather than list being empty. And if we have one element left, then we want our final link to be that element. In other words, return the link where the value is list.first. And with this technique, we're able to correctly skip across all components of the linked list.